So myself is Rahul Kambale, and I will be taking your 2 credit course, that is PHYC 107 Atomic and Molecular Physics. So this course is of 2 credit. So in earlier days, this course was of 4 credit, but due to some restrictions, so we have reduced it to 2 credit. So the name itself indicates that throughout this course, we are going to study about the atomic physics and the molecular physics. And of course, we know that molecule is formed by combination of atoms. So first, we will give the preference to the atomic physics. So we will get totally 20 to 22 lectures, and in these lectures definitely we will try to cover all the syllabi with 6 to 7 tutorials. Okay, so you can see that the first module is atomic structure and atomic spectra. So this is the module 1, and this is, I can say that most of this part you have already done in your undergraduate. Okay, but in detail insight, we will go for this particular thing. So this first module is divided into some parts. So the first part is of your revision of hydrogen atom. Then second means hydrogen, we know that that is 1s1. So it means it is a single electron system. Then the third part is multi-electron system. The name itself indicates that some atoms are there, those who have more than 1 electron. And the fourth one, this is, I can say that most important part throughout these basic physics, not just for atomic physics, but basic physics. So the behavior of an atom under the application of external magnetic and electric field. And that's why I'm using the magnetic and electric field. So that's why normally people they say that the behavior of an atom under electromagnetic field, because I'm going to apply the electromagnetic field also. Okay, so the first point, so this is what our syllabus actually I am showing to you. So there are basically 2 modules. So module 1 is related to atomic structure and atomic spectra, and the module 2 is related to the molecular structure and molecular spectra. Okay, so we will go in detail, and you will really enjoy this particular course, because so many things we have to do by our own hand and try to understand what is happening exactly over there. It is not just like some question is given and some answer has to be mug up and just write. It is not like that. So this course is definitely means some brainstorming kind of session is there. Means that course is designed in such a way that. So the first part is related to the hydrogen atom. Then in this case, whatever the wave function psi, what is the importance of psi, why it is used in this particular course, or what are the wave function of hydrogen atom. Then after solution to this particular total wave function, we will get some 3 indices, that is N, L, ML, what they indicate. So like this study will be depend on that. Maybe today we will go to the up to this part maybe. Then spin angular momentum. So this was a great discovery. Actually, we should respect that Stern and Gerlach experiment. So that experiment also we have included in our syllabus also. So definitely we will discuss about the Stern Gerlach experiment, where the idea about the yes, something is there which is related with the electron, and that then later on discovery is that yes, spin. And normally the spin of electron is denoted by small s letter, and it is always half. But I observe that most of the students, whenever we ask what is the value of spin of electron, immediately without thinking they say plus minus half. Very wrong answer. Spin is always half, and what are the possible different orientations, that is up and down spin. Based on that, there is a plus and minus half value, but spin is always half. Then we will see some in case of multi-electron system, definitely we will go for the central field approximation. Then exchange symmetry of wave function means formulation of Pauli's exclusion principle. So student, we should be being a physicist, we should always respect this Pauli, because this Pauli's exclusion principle is you may find everywhere. And depending upon Pauli's exclusion principle and another person as far as atomic physics, that is Hun. So both they have given very good insights to this atomic physics or molecular physics or whole physics. I can say that because of their both of their contribution, we may able to write the electronic configuration, and that is very important. Now you can see that whatever the properties of that particular atom or element, they are definitely based on what is the content of that particular atom. Okay, so content means of course electrons are there. Okay, so how those electrons are arranged, how they are going to interact, or what, how they will respond to the external stimuli. Whole everything is based on that particular electronic kind of thing. So, and how to put the electrons in different shells. You have learned in your school level also, that is K, L, M, N. These are the different atomic shells, and we know that S, P, D, F. So that basic also I will cover. It is not like that. If you don't know, don't worry. I will go in very conceptual way, and definitely we will discuss in detail. The third part, that is the atomic atoms in electromagnetic field. So means whatever the spectra which we are getting, and when we apply the external electric and magnetic field, so then there is a splitting. Splitting means what? You will try to understand that degenerate and non-degenerate energy levels. What does it mean? And of course, this whole atomic physics is based on some selection rules, and which are derived in quantum mechanics by using some parity or other kind of concepts. So we are going to directly use in this particular course as a selection rules. So basically, this throughout course, the quantum mechanics we are going to use just as a some tool, and definitely in quantum mechanics 1, as this course has also started, you will try to understand what is going to happen inside also there. But as far as atomic physics, I will clear all the concept over there. Then fine structure is there. So fine structure, then hyperfine structure, then X-ray spectra, then Stark effect, Zeeman effect, and Passenbach effect. Absolutely, these are the great discoveries in atomic physics, and they are at their own place with their importance also. They have their own importance. So this is about the first module. The second module is related to the molecular structure and molecular spectra. So what happens, student? Right now, you know, if I ask you carbon C, Z is equal to 6. Immediately, if I ask you can you tell me the electronic configuration? So you write always 1:2, 2:2, and 2p2. So this everybody knows, no problem. But suppose if I ask you, you have the oxygen molecule, that is O2. Okay. So if I ask you write down the electronic configuration for oxygen molecule, so we can't use this one. This is related for only atom. But for molecule, we have a different kind of system, that is molecular electronic configuration. And there you will try to understand that oh, this is one atom, then this is the molecular orbital, and then this is another atom. So this is oxygen, and this is O2. And this is the energy elements, y and y-axis. And I have 8 electrons here, I have 8 electrons here, then I have to accumulate over here. And like way, I have to write first construct the molecular energy level diagram. and then I can write what I want to say, the molecular electronic configuration, that is sigma 1s2, then sigma 1 star, something like that. So definitely we will discuss this thoroughly throughout this course, and you will enjoy it actually. Okay, so this is related to kind of thing, and then of course, whenever the molecule is going to form, then which type of bond is present. Either it is a molecule, maybe now you O2, O and O, same. So Z is same. So I can say that homonuclear diatomic molecule. Then if I take CO, I can take HF molecule. Then I can say that heteronuclear diatomic molecule. So I think we have restricted ourselves for diatomic, maybe for some where I may discuss about some yes, yeah, polyatomic also I will try to cover in this one if the time permits me. But this chapter is this module is really very interesting, and kind of book, but very well written. For means even though you will find that different chapters they are dedicated to small concepts. Electron spin, there is one separate chapter for that. Then magnetic means Passenbach effect, Zeeman effect. So whatever that effects will be there, I am going to use for this book for particular that kind of thing. Then this is Sobelman. This is another book for if someone is interested, then they can use. Then Cohen is there, atomic spectra, Lincoln. Then some modern physics books are also we can use because our this course it comes under modern physics also. Then this is for atomic part, and this book is for molecule also. But in this book, only molecular spectra is used, but not in depth insights. Means whatever the basic terminology, bonding, then percentage of ionic character, and electronegativity, and so many important concepts. For that purpose, we will discuss whatever the notes which is prepared by me. Then this is Herzberg. So Herzberg has both books, I think. So it has atomic book also. Yes. So we can say that this is number one and this is number two in whole atomic physics and molecular physics. Herzberg book is also available, but I'm not sure you will get it online or somewhere. This is very old book. Maybe our university, they have their some copies. You can have in situations are okay. When you come here, then you can visit to the lab, this library. Then this is the most important book, that is the Fundamentals of Molecular Spectroscopy. So maybe in the third semester, you have dedicated course, that is atomic and molecular spectroscopy. So whatever the last chapter was, that what earlier those we have a 4 credit, that fourth chapter was dedicated to the spectroscopy. Now we have separated and we have made the separate that course for that, because student they should get complete insight for atomic and molecular physics along with the spectroscopy, because spectroscopy is the application of atomic physics. Means quantum mechanics is a theoretical tool. Atomic and molecular physics is, I can say, that some scale, on that scale I am learning, and the spectroscopy is the application. Means is whenever we are doing something, some experiment or something like that, why we are doing, what we are doing, and for what purpose we are doing. So we are using quantum mechanics as a theoretical background, on which atomic and molecular physics, on that scale it is based. And what are the application? That is the spectroscopy is the application. So many people they ask you, what do you mean by the spectroscopy? Anyone can tell me what do you mean by spectroscopy? Students, what do you mean by spectroscopy?
Splitting of light.
Splitting of light.
So it can be the study of the interaction between matter and the electromagnetic radiation.
Okay, who gives this Parekh, na?
Yes, sir.
Yeah, very good. So you see that spectroscopy, he has given the answer, interaction of electromagnetic radiation with that of matter. Am I right? Like me, you have
Yes, sir.
given the answer. Yeah. So absolutely correct. So I will just little bit I will modify. The spectroscopy, it is nothing but it is the interaction of an electromagnetic radiation with that of electrons of an atom and molecule when those electrons are in the ground state. And spectroscopy is a very vast field, and this will give you the insight what is happening there, exactly fingerprint, how the atom is made, how it is responding, what type of quanta is coming out, what type of lines we are getting, these kind of things. Okay. So today, Sadhav, Sadhav, mute yourself. Okay. So let us start with positive attitude that yes, we will definitely try to cover the syllabus, and we will discuss all the points which are mentioned in the syllabus in detail with some good tutorial session, interactive session. Okay, so one announcement is that Friday, okay, you have an extra class at 9. So that is throughout this semester engaged by me. Okay, so you can see your calendar also. Okay, so that class is always taken by me, so I can give maximum time to you, and we can discuss so many things. So let us go back to the 12th standard, that is so today what we will see, just brush up class, that is revision of some hydrogen atom. So you have learned the Bohr model, then hydrogen spectral lines. Then I think yesterday batch C, definitely I hope they enjoyed the Frankel's experiment, which is a Nobel Prize winning experiment in physics, that is 1925. Then hydrogen atom wave function. Then we will get some 3 different Schrodinger equations for 3 different kind of things. Then quantum numbers. Maybe I think then throughout this week, I think I can say that then degeneracy relation, then selection rule for one electron spectra, shapes of atomic orbital, then radial function, then probability, radial probability function, then the shapes of atomic orbital, and then angular momentum and its space quantization. So this week maybe I will cover all this revision kind of part. Okay, and half of that part, but most of the part is remaining. Maybe 3 lectures I will spend on this one, and definitely you will see what is going to happen inside that. Let us start. So as see, you can see that first part chapter is that is atomic structure and atomic spectra. Structure and spectra, that is divided, and this is coming under the umbrella of atomic physics. So what is an atomic physics? Just have as a starting point. The name itself indicates that some type of physics we are going to understand, we are going to frame it, and we are going to work out which is related to the atoms. And of course, we know that you all learned that nucleus is there, and there are so many different shells are there, and something like that. Means what? It is a one type of a science which deals with the structure of electron cloud within the atom. One line understanding. How the distribution of electrons are there, how they are going to behave, who is going up, who is going coming down, and what is going to happen, who is allowed, who is not allowed. That all this kind of thing is based in atomic physics, and whole atomic physics is based on the two important foundation, that is Pauli's experimental principle and Hund's rule. Okay, and of course I can little bit just add on that because when I combine two atoms, I will get the molecule. So that's why I have written that atomic physics is a neighbor to the molecular physics. Of course, in that case, some chemistry, of course, definitely chemistry in your molecular structure and molecular spectra, some basic chemistry knowledge is required. And as someone has given very good answer that interaction of that electromagnetic radiation with that of electrons of an atom, that will result into spectroscopy. Similarly, in molecular physics, it is an interaction of atoms with each other, because two are coming together and one is formed. Okay, A and B is coming in, then I am getting C. Okay, so and a resulting structure, and then that we will be discussed. So as I say, if I want to start, so this is my tool. So this is my scale. What type of scale? So let us start. So everybody knows that there is a nucleus. Around that, there are different atomic shells are there, which are present over here. Okay, so let us start from this. So maybe in the 4th semester, you have dedicated 4 credit course for nuclear physics. Okay, then atomic physics is here, then molecular physics is here, and then chemistry. Why chemistry is there? Because how both atoms they are going to interact, because when two atoms combine together, what type of bonding is involved, and for bonding chemistry is there. And because based on that, that's why you can see that student in chemistry, physical chemistry is a separate specialization 100% based on quantum mechanics, means our physics. Okay, Misar Vaishnavi, please mute yourself. Misar.
सर म्यूटच आहे.
Okay, so this is the scale, and for what purpose I am doing? Application, optical physics and spectroscopy. Optical physics means it is related to, I can say that, laser or somewhere UV or visible something, and spectroscopy means you can say that ultraviolet spectroscopy, infrared spectroscopy, Raman spectroscopy. Means this is your 3rd semester part. So what is the importance of this course? We are going to make our base much more understandable, so that we can learn this atomic, these particular scales and their applications. So Those who want to take theoretical physics in future, those who want to come to the experimental physics for their work, atomic and molecular physics is everywhere same, and you have to understand it thoroughly. So that's why. So please concentrate on this particular course while when we are going to discuss. Of course, as I said, the quantum mechanics which are going to use, because if n this is the n equal to 1, 2, 3. But right now I will not purposefully use this particular n or something kind of word here. For your understanding, I will use K, L, M, and N shells. Why? Because dedicated understanding I have explained for this maybe in the next coming slides. So I have different compartments. In different compartment, different capacity of electrons are there. Though they are there or they are not there, that doesn't matter. But how to arrange them, that is given by Pauli and Holmes. Okay, so if the compartment is changing, then the states of electrons. So someone will ask you, what is a quantum state? I will write QS for that. Okay, yeah. So one thing I would like to clear here, I will not write all this thing. Now I said quantum state. I will not write quantum state. I have written QS. So you have to be much more attentive. It is not like that I should write each and everything. Okay. So quantum state. So quantum state is represented by these particular people, N, L, ML, and MS. And what are these? Of course, these are the quantum numbers. We will thoroughly discuss these kind of. So one quantum state or one particular state or related to that. So it is a combination of these particular four quantum numbers. But normally these three are okay. N, L, ML. As far as position of electron inside the atom. MS is a different part, but nowadays people they use okay, chalo usko bhi we can include there. But if I know these three people N, L, M, L, I can find out the everything related to the position of electron. If I know the position of electron, then I can know the energy. If I know energy, I can know the momentum. That's all. Energy, momentum, and position. These three things we want to find by using quantum mechanics. And that is what that's why it is said that the quantum states. And once I know that, then from which level to which level they are jumping, they will give me the electronic structure. And once I know the electronic structure means spectroscopy. Okay, and then as I said, the interaction between electromagnetic radiation and the electron system. So let us differentiate much more part. So as far as my understanding related to the atomic physics, what are the basic aspects? So I figured out by some here and there some books. So I figured out some three. You may find some more or maybe less. So the first is that the electronic structure of atom. Electronic structure means how now the name itself electron means electronic, how the arrangement of electrons are there. Then what are the spectroscopic techniques? For what? To measure the electronic transition between different states. Now the word has come in different state. Suppose I have N, L, ML. Suppose this is one state. And I have a N1, suppose this is N2 and L2 this is ML, something like that too. This is what type of transition? Either up transition, either down transition. That doesn't matter for me right now. Okay, here. Then variety of chemical elements means periodic table, because everything is with respect to that periodic table, na? How it is arranged or how it looks. Okay, and we know that S, P, D, F. Based on that, there is a dividation of family. We will discuss thoroughly. So this is the main thing is that one electronic structure, spectroscopic interaction, and periodic table. Once I know about these three, then I think I am very close to the atomic physics. Okay, what is the goal of atomic physics? Of course, it is the understanding the structure of atoms and their interaction with one another. And as I think in this introductory slide syllabus, I have already mentioned that how it is going to respond to the electric and magnetic field. Now, atoms, what is the constituent of atom? They are positively charged nuclei. then negatively charged electrons are there. Then atom is some Greek word that is actually it is a atomos. Means what? Uncuttable, indivisible, the smallest component of matter which cannot be further divided. So if you means actually maybe I will discuss the timeline for atomic structure and model. We will see very soon. So I think yesterday batch C they have already understand this one, but again let us begin at 9:32. Our actual class has started. So what are the basic properties of atom? Because as a physicist or as a science person, I know that what are the basic properties of atom. So atom, I have defined very simple language because most of the students they have different understanding. That is also correct. I am not saying right or wrong. It is the smallest constituent unit. See, this word has very important meaning, student. Constituent, because by a proper scientific way, this meaning has very good means. What exactly it mean? Okay, so that's why always whenever you are going to talk about the atom, if someone asks you atom, don't say that it is the smallest particle, it is the smallest thing in the universe. It is not like that. It is the smallest constituent unit of matter having some chemical properties. Now you will say that why it is chemical properties written. As course moves on, by default we will understand that why Kambale sir has mentioned chemical properties. Okay, so that is one question or one thing I have left with you, or if you know, that is really good. So what are the basic properties of atom? So whenever you purchase one mobile or something like that, so you always see the specifications and configuration. What was the processor, what type of display is there, what type of battery is involved, something like that. So if I ask you, which type, which mobile you have taken recently, 5 years, immediately you will start not mentioning 1 second late. This phone I have taken and these are the specifications. Likewise, if someone asks you what are the basic properties, right now those are in front of you, but you ask yourself, really I know these properties before Kambale sir has displayed? Because these are the means very important. If you are trying to learn the atomic physics, then what are the basic properties of that atom, so I can start my further study. So the first is of course just like mobile or other kind of size and something like that. Atoms are very small. Their radius is of 0.1 nanometer. Then atoms are very stable. Okay, atoms, they are very stable system. Okay, what do you mean by stable? Because they do not spontaneously break apart into small pieces. We cannot divide further, na? Or collapse. Okay. Therefore, means what I want to say that whatever the internal force, okay, now I am here, okay, and if I am very strong or something very stable, means whatever the internal feeling or internal whatever the power which is, that is very quite strong, okay, like that. So in this case, what I want to say that atoms are very stable. We are not going to break into pieces. It is not like that. Chalo, carbon atom we have taken. Suppose we will make 1/4 part this, 1/4 part this, and 1/4 part of this. It is not like that. It is a whole atom C6. It is like that. Okay, means what? Whatever the internal forces that hold atom together must be in equilibrium, of course, equilibrium, and of course, whatever the forces that pull the parts of atom together, they must be opposite. This together. If I want to break, I should do, but I am not able to break means they are whatever the forces they are bounding together, they are opposite. So this is one important basic properties of atom. I think everybody knows. The third property you know, everybody knows atom contains negatively charged electrons revolving around the nucleus. Yes, of course, 12th standard we learn, but they are electrically neutral. See, yeah, means they are electrically neutral, but they consist of this kind of thing. Okay, and as per as our course or throughout this atomic physics is standing based on this fourth and important property. Atoms emit and absorb electromagnetic radiation. And suppose this is the atom. If it absorbs, it will show some transition, it will give something. Means what? They are responding to the incoming stimuli, that is electromagnetic radiation. And then this will give you the birth to the spectroscope. And depending upon different years, as years goes on further, to account the whatever the spectroscopic data obtained experimentally. So one statement I would like to do, our physics is pure experimental science. And whatever the results which we are getting based on that, theory is also developed. Okay, so why Frank and Hertz they got a Nobel Prize? If time, maybe we are coming to that part. There I will explain. So several years, whatever the spectroscopic data is obtained experimentally regarding the atomic structure, means time to them they are proposed. Okay, suppose today I have proposed something. 10 years after, suppose you are going to propose something. So if I propose something, then this is my model, RCK model. Then after 10 years, if you propose, then your model, something like that. So many people, they will ask you, write a short note on atomic models. I don't understand what type of question it is there. It is not means like that. So what do you mean by atomic model? That actually first try to understand the students. So year wise, different evolution is going to take place in atomic spectra. If that particular situation, whatever that XYZ person has got the result, he has proposed his own theory, then the name is given that this is this model. Okay, so that is called as a model. Now, if I ask you, what do you mean by atomic structure? So by default answer, atomic structure is nothing but atoms which consist of central nucleus and around which electrons are revolving, and in the center there are neutrons. So atom consists of proton, neutron and electron, and this is called as atomic structure. No. School level definition for understanding? Okay. Now, being a PG student or physics student, atomic structure, whenever you listen this word atomic structure means what? Yes, this is a one type of structure where, of course, inside structure, which is the electron, how they are distributed, how electron, I mean, proton and neutron, they are there at their side. Atomic structure gives what? It gives the relation between macroscopic properties of matter and its microscopic structure. So student, this word is very important. Macroscopic and microscopic. Now you are quite, you know what do you mean macro and micro. Okay. Now you will say that why it is written macroscopic properties of matter and its microscopic structure. See, solid state physics, of course, definitely, I don't know, maybe I may be involved in that. So, solid, it has some basic properties, that magnetic property, dielectric property, something like that. So, whatever the properties of that coming, that is because of what, how the atomic structure is made. Okay, so the macro means what? I can see means it is not like that I can see or I can't say. I can this one. Macroscopy means what? Those things which can be measured experimentally. Current you can measure now. Of course you can measure, but have you seen the electron? No, that is a microscopy. Okay, so Microscopic structure means how the arrangement is going to take place, and macroscopic means yes, I got some property. Suppose I got the magnetic hysteresis, one magnetic property. Suppose if I got the dielectric constant, Curie temperature, this is epsilon Tc. So everything. So my properties which is coming because of the insight. And what is insight? Microscopic structures. Microscopic means what? How these are the tiny things they are arranged within that. So this is what the main kind of thing, and I think this same thing I have mentioned on there. So let us begin with the timeline of the atomic structure and models. So as I see 1813 AD, Jadhav, camera band kar baba. Okay. So Dalton. So now we are going to spend some 2 or 3 minutes on the timeline. Okay. Dalton has proposed his atomic theory. See, student, see the year, 1880. Everything is composed of atoms, which are indivisible building blocks of matter and cannot be destroyed. All atoms of an element are identical. Suppose Z is equal to 6 carbon. It is not like that means one carbon in Pune University carbon is of this 0.1 nanometer size. In Kolhapur it is 0.2 nanometer size. It is not like that. Na? All atoms of an element are identical. This is what one is saying. That is correct. The atoms of different element vary in size. No problem. Carbon and oxygen. Of course, content is different. Okay. And atoms cannot be destroyed or subdivided. This is what proposed by Dalton in 1830. Now, 1830 to 1897. See how much years spent. And you know that this Sir J.J. Thomson, he was doing one experiment of electronic discharge, and he has given his plum pudding model and figured out the electron. And then he proposed as yes, size of an atom is 10 raised to minus 1 angstrom. Okay. Then immediately 1897 to 1912. So he said that nothing inside atom, but he figured out something in the atom. So 1897 to 1912. See how much years was there. Okay, we have spent, and actually Rutherford, maybe Gardin and Marsden, maybe these two students, they were doing the experiments of controlling the alpha particle. Alpha particle is just like an elephant which is running in open grass and hitting to the wall. Okay, he was doing one experiment and he observed some 3 basic findings. Means the scattering of that particular alpha particle by the gold thing kind of thing. He observed 3 observations. These are means what? 1,200 alpha particles scattered, then 1,002 alpha are getting rebounded back. Okay, so they leads to the discovery of nucleus. Means elephant is there which is running towards the wall. So wall should break, na? But elephant is rebounded back. Means something is there inside atom. Electron was known. Something is there apart from electron because of and which is very heavy. That's why this elephant come back, alpha particle. And that's why he has given the name something is there, means whatever the mass of whole electron is concentrated somewhere else. And that is called as a nucleus. And then the nucleus discovery is there. And of course, which is inside there. So it is 10 raised to minus femtometer. Okay. And then in 1930, but Rutherford, you know that there was a one basic problem, that planetary model and sustainability, how it will sustain. Because if the moving thing is there, moving thing should radiate something. And if it radiate, then atomic structure has to be collapsed. But atoms are stable, they are not collapsing. What we can see, we can predict about it. Atoms are there, nucleus is discovered, electrons are there, electrons are revolving. If that electron is revolving and this positive kind of thing is there, it is negative kind of revolve and collapse. But that is not happening. Then Bohr has given some ad hoc basis. I know nothing will happen there, but risk. Who should take the risk? Bohr has taken the risk, and he has an ad hoc basis. He has given two bold statements to the Physics Society people. What he said that, just hold on. What he said that there exists some special orbits of electron in which electron cannot radiate the energy. Means what? This is nucleus, means massive is there. These are the electronic shells, and this electron is there. No problem, move. No problem, move. But electron cannot radiate the energy. But when energy is radiated, when electron make a quantum jump from one allowed orbit to the another allowed orbit. That is what he said. Means this to this only. It is not like that. चलो यहाँ तक आ जाता हूँ फिर वापस जाता हूँ. It is not like that. From one compartment to the another compartment. This is like that. And then he has considered the wave particle duality nature. Of course, he has considered. Okay. Then he has given some 3 to 4 postulates. You know that this is circular. It is moving in the circular orbit. Then this is the postulate for the quantization of energy. Both Frank and Hertz, this is the postulate given because this is the postulate. But experimental evidence is given by the Frank Hertz, and that's why they got the Nobel Prize. Okay, and this is the third postulate. Means what? The electron, in spite of its acceleration motion, does not radiate the electromagnetic radiation while moving allowed orbit, because these are the allowed orbit. Orbit means what? K, L, M, N, no problem. Okay, that is what they want to say. And when there is a quantum jump, which is shown over here, then one means radiation will come out, and that's why if different level is there, then different energy is there, and that is equal to h nu, or you can write delta equal to h nu, and whatever the nu is there, that is the frequency of that electromagnetic radiation. So throughout this course, E equal to h nu or E equal to Sc upon lambda, Sc is equal to 1240 eV nanometer. This means being a physicist, this should be in our blood. Okay, this must know. Don't say that I don't know. It is not like that. This we must know. Okay, so this is what this, and throughout this course, electron volt is the standard unit which is we are going to use for this atomic and molecular physics. So this was just atomic kind of thing. So let us start the revision of hydrogen atom. So if I said the hydrogen atom, what is a hydrogen atom? What is its constituent? Okay, so I have shown here one proton and one electron. Okay, so hydrogen atom with single electron circulating about the nucleus that has a single positive charge, and the atomic number is 1. Count one proton, and the atomic mass number, of course you know that. See, these basics you have learned in your undergraduate. So we will jump a little bit here. So everybody knows that the potential energy of an electron and a nucleus. So electron is negative, nucleus is a positive, and they definitely attractive kind of force is there, and that's why the potential energy will come into the negative sign. So U is equal to, so it is proportional to minus 1 upon R. So this is 1 upon 4 pi epsilon 0 E squared divided by R. And what is R? R is the radius of the orbit. This you are done in your undergraduate. So negative sign means what? Of course, this is a attractive kind of thing is there. Then radius, which is directly calculated, that is Rn is equal to A0 n square. Right now, just this is a principal quantum number. Definitely, I will explain what does it mean. So 1, 2, 3, something like that. But most of the students are really surprised. Do you write n equal to 0, 1, 2, 3? But how it is 0? Okay, so why whenever you are writing means understanding is should be very clear. What is A0? A0 is maybe this A0 will be throughout this course maybe coming, that is Bohr radius. So if I draw this one, suppose this is my nucleus and this is A0. Otherwise we can show like this na, अरे इसके ऊपर ही shell लगाओ. No na, it is not like that na. A0 separation is there from nucleus and you are the first n equal to 1. So that is 0.529 nanometer. And this everybody knows that En is equal to minus 13.6 divided by n square into electron. So this is your, I can means you are done in the your undergraduate. This Rydberg, this is used in molecular spectroscopy or chemistry people na, they use Rydberg unit. Okay, so that is what, but the meaning is same. Okay, so electron energy is quantized. And remember student, in any equation, whenever Planck constant is coming, that system is quantized. Means it takes specific values. It is not like that, chalo n equal to 1h, right? N equal to 1.2, 1.3. It is not. No, quantized. Few amongst many, not all. Few amongst many. When it dedicated. Okay, only selected values, discrete values. Okay, that is what they mean. So if I put n equal to 1 in this equation, so I will get minus 13.6. And n equal to 1 means what? Ground state. The law of nature. System always try to occupy the lower energy state. So n equal to 1. And of course, lower energy state means what? This is the ground state. Okay, so n is equal to 1. Ground state. Then if I go to the higher state, n equal to 2. Okay, now you suppose some energy is coming. So from this to this it will go. N is never negative. It will not go here. Okay, so from this to this, and then when it comes down in 10 to minus 8, then quanta of radiation will come. So n equal to 1 is the ground state and it is a non-radiating state. So this is add-on for today to you. Ground state is not non-radiating state. It will never emit anything. It's because since it is the ground state. Okay, lowest. And negative signifies what? Bound system. Bound forces are opposite. Okay, attractive force is there. Both are attractive to each other. Okay, that is the bound system. So complete this part. So this you have learned just for your understanding, I assure, because the hydrogen spectra is there. One thing is use R infinity, that is the Rydberg constant for infinitely heavy nucleus. Okay, so this is you have learned. So what is the point of understanding? Important for hydrogen spectra, you know this equation, R infinity in bracket 1 upon n f square minus 1 upon n I square. So NF means final state, NI means initial state. And based on that, Lymer, Balmer, Passon, Brackett, Puffin, and Humphrey, NF equal to 6. Okay, and this is what's shown over here. This is just first class, just brush up the model. That's why I have shown here. Okay, so this is what involved over there. Then how the hydrogen spectra looks, because we are going revision of hydrogen atom. So an atomic physics spectra is there. So we must know. That's why this something is added to you. So n equal to 1 equal to 2, 3, something like that. And you use the value, this En equal to minus 13.6 divided by n square electron volt. So you will get your answer here. Okay, and now from this to this state, I need to give some energy. Okay, and suppose from this state to this state, if it is coming, then suppose my electron is go to the higher state, n equal to 2. So you can see that it has minus 13.6 electron volt. So if I give the plus 13.6 electron volt, then it is called as a binding energy of that. Okay, so this important thing is that. So this is the hydrogen spectra. Typically, everybody knows. So you can see that electrons' energies are quantized. They take specific values. Minus 13.6, minus 3.4, 1.05, because this n is fixed. And this is what they are. So binding energy is the amount of energy which is provided to release the things. Okay, means the energy which binds the electron to the nucleus from that particular level is the binding energy. And suppose it goes to the this two level and this one level. If I take the difference between these two, definitely will come positive, because this is minus 13.6 and this is this one. And in physics, always we do higher minus lower. So delta E, E2 minus E1. So minus 3.4 minus 13.6, it will give you 10.2 electron volt. If I give the 10.2 electron volt, so this is this is the amount of energy required from this to this. If I give 10.2 EV electron volt, then from ground state to the first excited state, this will go. And like with the second excitation is like that. So this is what the most important thing you need to understand as far as the this in a hydrogen spectra. So what do you mean by a spectral line? Because someone has given very beginning spectroscopy means spectral line. Okay, so you can see that electron. This is cell. So these are the inner cell electron. These are the outer cell electron. If I am dealing with outer electron, then I will get the optical spectroscopy. But if I deal with the inner electrons which are very close to the nuclei, tightly bound, then this is called as the X-ray spectroscopy. Maybe last part of this topic is the X-ray spectra. So that time we will discuss. Means what? Whatever the emitted radiation after being dispersed by a suitable spectrometer, because instrument which are used, becomes, we can see that some lines they are concentrated and they will give you the number of discrete wavelength, and each of this wavelength component is called as a spectrum. You know that sodium doublet is there, this is there, so that is a spectral line for sodium. Rainbow color, 7 lines are there, so these lines, each line, each color gives you the particular lambda, and that is the spectral line for that particular kind of thing. So the whole family of spectral lines is called as a line spectra or atomic spectra. So this atomic spectra, this is the spectral lines. Okay, and okay, this is not required. In the tutorial you may understand it. So very quickly I will discuss, because only 1 minute is remaining. So there is a correction to the nuclear motion also, because it is not like that, because so far electrons are revolving, but it is not the thing that both are moving with nucleus and this one. In that context, the reduced mass is coming into the picture. Okay, so reduced mass, classical mechanics you must have learned. It is the effective initial mass of two bodies when they are in motion. Okay, so one problem is based on this, which is given in your tutorial sheet. That time you will understand. Okay, so I think time is up. So if any doubts, anything, you can always discuss with me. Otherwise, you can interrupt me also. It is not like that you should not interrupt. You can ask definitely. So just warm up class, warm up just for atomic physics. Some things I have discussed. So maybe tomorrow may be the holiday, but on Friday we will meet at 9 a.m. Okay. So any doubt you can ask, because 10 a.m. is there.
I doubt, but since we have another lecture, can you?
Yeah, you can email me, or you can even though when on the Friday in the beginning you can we will start with your query. No problem. Huh?
Thank you, sir.
Yeah. Okay. So student, I am going to end the meeting. Okay. Chalo, let's enjoy
Okay,
the
sir.
day, and bye. See you. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.